All right, welcome back, guys. Today we have actually a very short lesson. We will be discussing infinite limits. There is a difference between limits and infinite limits. Remember, limits at infinity meant that we were taking a limit as x approach infinity, and we were looking for what output it was approaching. Versus today, it refers to limits whose outputs are actually approaching infinity. So in other words, as x approaches a specific number, the y value is either going to positive or negative infinity. Okay, so I actually just have two very short examples. I will show you both two ways to approach these problems. Okay, so the first one is, okay, obviously let's not forget to use substitution. That's the very first thing you should try with a limit algebraic. Okay, so if I put in a 1 into this function, I will get a 1 on top for sure. 1 minus 1 is 0, 0 squared is 0. Okay. On a previous video, I showed you that if you obtain either 0 over 0 or infinity over infinity, you would have to further explore the idea because it was an indeterminate form. Cool? And we specifically discussed actually that the presence of 0 over 0 meant that you had an asymptote. I'm sorry, not an asymptote. I take that back. My apologies. 0 over 0 meant that you have a whole. Okay? And then infinity over infinity, those typically tend to lead you towards some kind of asymptote, whether that is horizontal or slant. Okay? Now, we don't have either one of those cases, so this is not an indeterminate form like 0 over 0 or infinity over infinity. We have 1 over 0. If you have this, what you automatically need to think about is that you have a vertical asymptote. Okay, so let's first start out, how do I approach this in a graphical sense, since we are going to be discussing vertical asymptotes. Okay, so from a graphical sense, the fact that 1 is giving you 0, that means that you have a vertical asymptote of x is equal to 1. Okay, now from algebra, I know that the power of the denominator is much larger, which in this case is x squared versus 1 on the numerator. That means that I have a horizontal asymptote at 0. So it looks like this. Okay, some really quick exploration. If I plug in the value of 0, 0 minus 1 is negative 1, negative 1 squared is 1, 1 over 1 is 1. That tells me that I'm going to be here, and that by the definition of asymptotes, this graph should look something like this. Cool? If I put in like a x value of 2, 2 minus 1 is 1, 1 squared is 1, 1 divided by 1 is 1, so that'll be 2, 1, so that would also look something like this. Okay? So now, if I take this limit, remember that in order for a limit to exist, the left and the right would have to approach the exact same value. Okay, so as I am taking the limit as x approaches 1 from the left of this function, so from the left, I am going towards infinity. And limit as x approaches 1 from the right, I'm also going towards infinity. Now, honestly, I don't remember if I talked about this in another video, but I will go ahead and mention it here. Okay. The fact that they're both going towards infinity, technically speaking, we would say, okay, then that means that the limit as x approaches 1 of the function that we were given, which in this case is 1 over x minus 1 squared, is infinity. Okay? Now, there's some textbooks out there, and then really there's some, I would say, disagreement overall of whether or not an answer can actually be infinity. Because by definition, a limit should be approaching a specific unique number. Infinity is not a unique number. So technically speaking, by that definition, we should actually say that the limit does not exist. However, I do personally believe that it is important for us to understand whether, I don't care if it's a one-sided limit or both-sided limits, if you are approaching infinity. So I just kind of wanted to address that, depending on where you're at, depending on what your teacher, your professor wants, just kind of follow what they're requesting from you. Okay, so in my class, I do like to mention that technically speaking, by that definition, the limit shouldn't exist, but I do want them to know that it's going to infinity. So the answer for our first example will then be that I am going towards infinity. Okay? Let's look at example number 2. Same thing, I'm going to approach it graphically. By plugging in 1, this will create a 0, which means I have a vertical asymptote. Graphically speaking, I have a vertical asymptote of 1. I am still bigger on the denominator, which means I have a horizontal asymptote at 0. Plugging in 0 this time, you just got to be careful. 0 minus 1 will give me negative 1. 1 divided by negative 1 is negative 1, so that actually puts me here. So by definition of asymptotes, this is looking like this. And this time, if I put in a 2, 2 minus 1 is 1, which would create a 1, which would look like this. Cool? So based on this graph, from the left side, so the limit as x approaches 1 from the left of 1 over x minus 1 is equal to negative infinity, while the limit as x approaches 1 from the right of 1 over x minus 1 is going to positive infinity. Therefore, I can go back and say, well, technically speaking, this limit does not exist since the left and the right are not approaching the same value. Okay? So, in my opinion, this is pretty simple if and only if the function is simple enough for you to graph it and your graphing skills are relatively good. Okay? But like I said, I was going to try to give you two techniques to try to approach this. So let me go ahead and erase what I have here so I can show you the other technique. Okay? So let's go ahead and erase both of these graphs. And the other technique, once you know it's a vertical asymptote, involves actually looking at it from the perspective of left and right. So the limit as x approaches 1 from the left of 1 over x minus 1 squared. Okay? First, what you're going to do is you're going to ask yourself, okay, being from the left, that means that I have to be less than 1. And I have to pick a number that's really, really close to 1. So just so I can give you an example, I'm going to choose like 0.999 repeating minus 1, and then I got to square that. Okay? All right. If this goes on forever, 0.99999, and I take away 1, what that means is that I am going to end up with a negative 0.000000, lots of zeros, lots of zeros, and then a 1 eventually, and then I got to square that, right? Okay. So by numerical analysis, the fact that I'm squaring a negative number would make it into a positive, and what that's going to do, it is going to make it into a very, 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 very small number. Okay? So remember my analysis earlier where I had like 1 divided by 2, it was 1/2, 1 divided by 3, it was 0.33, 1 divided by 4 is 0.25. So that number was getting smaller because the number I was dividing by was getting larger. The number I'm dividing by is actually very small, so it's going to do the opposite. Dividing by a very small number is going to throw you into a very large number. So 1 divided by a hugely small number will actually go to a very, very large number, taking us to infinity. Okay? So now, I'm going to do the same analysis from the right-hand side. So I'm going to go ahead and switch this to a plus. So let's say we do limit x approaches 1 from the right side of 1 over x minus 1 squared. This time, make sure it's on the screen. Yes. I am going to utilize something on the right side like 1.00001. So it'll be 1 over 1.00001 minus 1. I'm going to square that. That results in 1 over 0.00000, lots of zeros with a 1, squaring it, which now I want to bring your attention that it basically takes me to the same step as here. The only difference is this one was negative and this one was positive. However, because they're both being squared, it's still going to result in a very, very small positive number, like 0.0000, lots of zeros and a 1. And by the same reasoning, if I take a number and divide it by a very, 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 very tiny number, it's actually going to go towards infinity. Both plus from the right side and the left side are approaching infinity. Therefore, because of that, I can go ahead and say that this is going to go towards infinity. Okay? Let's do that same analysis over here, and then we'll call it a day. Okay? So, from the left side and from the right side. So we got the limit as x approaches 1 from the left of 1 over x minus 1. So let's say I substitute, again from the left, 0.999 repeating in minus 1. So that's going to leave me with 1 over negative 0.0000, tons of zeros with a 1. Very small number. So 1 divided by a very, 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 very small number will result in a very, very large number, but because it's negative, it's going to go towards negative infinity. Limit as x approaches 1 from the right side of 1 over x minus 1. I'm going to choose 1.0001, so I'll do 1 over 1.000, lots of zeros with a 1, take 1 away. That will result in a positive version of 0.000 with lots of zeros and then a 1. Positive divided by positive creates a positive. The fact that this is very tiny, it is going to go towards positive infinity. Therefore, because they are opposing, the answer will be does not exist. Okay? All right, guys. Well, like I said, I was going to keep it very simple, very short for this one. I think either one technique that you feel more comfortable works. Personally speaking, I don't mind using the number sense idea. I feel comfortable doing it. But if you think graphing would be best for you, then make sure that you utilize those skills that you have to get the results that you want. Okay? Thank you for watching, and we'll see you next time. Take care.